Here we have a question based on mean free path. The question is medium in our difficulty level. The question says the mean free path of a gas. The mean free path of a gas with molecular diameter d and number density n can be expressed as. So we have to express the formula of mean free path. And what is this number density? This is nothing but number of molecules per unit volume. And we know what is the diameter. Diameter is given to be d. Now, mean free path is nothing but the average distance traveled by a particle during successive collisions. Average distance traveled by a particle during successive collisions. And we know that mean free path is inversely proportional to diameter square. And mean free path is also inversely proportional to number of molecules per unit volume. Okay? And we can see only option D has this legitimacy. And you know the exact formula for mean free path would be this. It is 1 upon root 2 n pi d square, where n is the number of molecules per unit volume and d is the diameter of our particle. So we can go and mark option D as the right answer for our question. Here we have a question based on motion under gravity. The question is medium level in our difficulty. And it says that a ball is thrown vertically downwards with a velocity of 20 meters per second from the top of our tower. So we know what is the initial velocity. It has the value of 20 meters per second. Okay. It hits the ground after some time with a velocity of 80 meters per second. So the ball goes down like this, and it hits, boom, with 80 meters per second. Nice. So we know what is the magnitude of final velocity. Nice. The height of the tower is. So what is the height of this tower? This is the question. We know what is U. We know what is V. We have to find the height of the tower. This is the question. Now, how do we solve these questions? Well, remember, do you remember the third equation of motion? What was the third equation of motion? It was V square is equals to U square plus 2as. Do you remember this? Yes, we remember it. So the equation is V square minus U square is equals to 2as. Okay? Yes. Now, let's put the value of V. We know V is 80. So 80 square. And U is 20, so 20 square. And you can see in the direction of this velocity, we have the acceleration. Acceleration is also in the downward direction and its value is 10 meter per second square. Okay, so let's put the value of A as 10. So we have 20 times S. What is S? S is the height of the tower. So let's put H over here. And from this we can see H is coming out to be 80 square minus 20 square divided by 20, and this is giving us 320 minus 20. This is nothing but 300 meters. Yes. So we got the height of the tower. Height of the tower is 300 meter, and we can now go and mark option B as the right answer for this question. Here is a question on Boolean algebra. The question is easy, medium or difficult. Let's check our difficulty meter. Oh, it is easy. This is easy. We don't have to be afraid. So question says for a logic circuit, the truth table is. So this is our logic circuit. And what is the truth table? These are the options. They seem to be really scary. Let's not look at them for a while. So here is our circuit. Let's try to figure out the truth table by ourselves. Now, A enters through a NOT gate. A enters through a NOT gate. What will happen? A will be reversed. So we will have A bar. And then B enters a NOT gate. What will happen? B will be reversed. B bar. Okay. Now, A bar and B bar enters a NOR gate. They enters a NOR gate. Now, if it was simply OR gate, if that was simply OR gate, then we will have A bar plus B bar as the output. But this is not an OR gate. This is a NOR gate. So this will be reversed. Yes. So this is our final output. This is final output Y. Now we can apply De Morgan's rule now. We can write this as A double bar dot B double bar. Yes. And this is nothing but A dot B. So according to De Morgan's rule, we have this formula. And we can finally say that final output Y is nothing but A dot B. Now let's draw our own truth table. So we have A, we have B, and we have Y. Now values are 0, 0, 0, 1, 1, 0, and 1, 1. Now let's do dot. So 0 dot 0 is 0, 0 dot 1 is 0, 1 dot 0 is 0, and 1 dot 1 is 1 dot 1 is 1. Yes. So final output should be 0, 0, 0, and 1. Okay. Now let's check our options. Final output should be 0, 0, 0, and 1. So option A is wrong. Option B is wrong. Option C, 0, 0, 0, and 1. Option C is right. And option D is wrong. So only option C is the right answer for our question. Here is a simple question on electric dipole. And the question says that a short electric dipole has a dipole moment of 16 into 10 raised to power minus 9 coulomb meter. So there is a really short electric dipole, plus minus, and this is the dipole axis. So the dipole moment P, which is QD, it is given in the question. It has the magnitude of 16 into 10 raised to power minus 9. Okay. The electric potential due to the dipole at a point at a distance of 0.6 meter from the center of the dipole situated on a line making an angle of 60 degree with the dipole axis is. So we have a cute little point, point A. And this point A is situated on a line which makes an angle of 60 degree from the dipole axis. So we have to find what is the potential at point A. What is the potential at point A? Now we understand the question. We have to find the potential due to an electric dipole. Now let me just suggest you what is the formula for finding this potential. Just remember that in case of a point charge, the potential is inversely proportional to R. We already know that V is inversely proportional to R in case of a point charge. But in case of dipole, V is inversely proportional to R square. Now I am going to disclose you a simple formula. The formula is like this. Potential at any point is equals to Kp cos theta upon R square. This is how we get the potential. Let's quickly put the values and get the answer. K, we know, is 9 into 10 raised to power 9. And P, dipole moment in our question was given to be 16 into 10 raised to power minus 9. And cos theta, cos of 60 degree. What is cos of 60 degree? It is half. Okay. Then we have R square. R was given in the question as 0.6 meters. So we have 0.6 square. Now we can just solve it and we will get 200 volts. So the final potential at point A is 200 volts, and we can go and mark option D as the right answer for our question. Here is a question on surface tension, and the question is on the topic of capillary rise. So question says that a capillary tube of radius small r is immersed in water and the water rises in it to a height small h. So what do we have? We have a capillary tube and we dip this capillary tube inside water. Now what will happen inside the capillary? Some water will rise. And it is said in the question that the water rises up to a height of small h. This is the height up to which water rises. So very nice. We have a little meniscus and we can see how cute it looks. Okay. Now what do we have? The mass of the water in the capillary is 5 gram. So in this capillary, we can see some water has risen and the mass of this much portion. The mass of this much portion is given to be 5 gram. Okay, we will call it M1. So there is some force M1G on this portion due to gravity in the downward direction. Again, I will say the mass is m1, and due to this mass, there is some force, gravitational force in the downward direction, m1g. Fine? Fine. Now what do we do? Another capillary tube of radius 2 small r is immersed in the water. So we bring another capillary tube and its radius is twice of this previous capillary tube. The mass of water that will rise in this tube is. So what mass will rise in the other capillary tube? This is the question. Now, let's try to get the formula in terms of this height, this mass, and the surface tension of this capillary rise. The formula is very, very simple. We can see the angle of contact the water can make with the glass is actually 0. So in our case, the force due to surface tension is directly in the vertical direction like this. Okay. What is the total value of force? What is the total value of force? Very simple. It is surface tension times length. What is the length? Length is the length of this circle. So this is T times 2 pi small r. It was given in the question that this radius was small r. Okay? Okay. Now, this is the force in the upward direction, and you can see this yellow portion. On this yellow portion, there is some force in the downward direction, which is equal to m1g. These two forces balances out. Wow, wow. So we got our first equation, T times 2 pi r is equals to m1g. Nice. We are so happy. Now let's try to imagine another capillary tube. What is the radius of the other capillary tube? It is 2r, not r, 2r. So there will be some upward force, right? The upward force due to surface tension will be T times 2 pi, 2r this time. Yes. And the mass which rises in the other capillary tube, let it be m2. So we will have m2g. Instead of m1g, we will have m2g. Okay? Okay. Now what do? We will divide these two equations. Yes, that looks good because many things are going to be cancelled out. And you can see we are getting about 1 upon 2. This is equal to m1 upon m2. Everything else gets cancelled out. Wow. Now, from this we can see what is m2. What is m2? m2 is equals to twice of m1. What was m1? m1 was given to be 5 gram in the question. So m2 is equal to 10 gram. Now we can mark option A as the right answer for our question. Here is an interesting question based on resistivity. And this is a rather simple question. The question says that which of the following graph represents the variation of resistivity with temperature for copper? So for a metal copper, what is the variation of resistivity with temperature? And these are the 4 options. Resistivity with temperature. Now first thing first. For metals, as we increase the temperature, what do you think? What will happen to resistivity? Does the resistivity increases or it decreases? For metal, as we increase temperature, does the resistivity increases or decreases? It actually increases. So option C is wrong, option D is wrong. Okay. Now, let's concentrate on A and B. In both these options, resistivity is increasing with temperature. Now, what do you think is the variation? Is it linear or non-linear? Well, I will tell you that linear is a good approximation, but that is only an approximation. For small range of variation of temperature, we can say the variation is linear. But if we talk about a huge range of temperature variation, then the variation is experimentally found out to be non-linear. So in our question, we can mark option A as the right answer. Here is an interesting question on electromagnetic wave. The question is medium in our difficulty level. This is actually based on simple concepts. So the question says that the ratio of contribution made by the electric field and magnetic field components to the intensity of an electromagnetic wave is very interesting. So we have an electromagnetic wave. This is made up of electric field and magnetic field. Now, the electric field will contribute something in intensity. The magnetic field will also contribute something in intensity. What is the ratio of these contribution? This is the question. What is the ratio of contribution in intensity due to electric field and magnetic field? And these are the four options. Okay. Now, first of all, let's be clear with intensity. Intensity of an electromagnetic wave is actually proportional to energy density. Intensity is proportional to energy density. If energy density is high, intensity is high. If energy density is low, intensity is low. So we have this relation of proportionality. Now, why did I give this relation of proportionality? Because we know the formula for energy densities due to electric and magnetic field. These are the average energies per unit volume due to electric field and the magnetic field. What is E naught? E naught is the amplitude of the electric field. And what is B naught? B naught is the amplitude of the magnetic field. And these two also have some relation. We can see the relation is E naught is equals to C times B naught. This is what we get from Maxwell equation. And there is another equation for C. What is C? C is the speed of light, and speed of light comes out to be 1 upon under root mu naught times epsilon naught. Great. Now, using these two equations, let's try to compare the energy densities due to electric field and the magnetic field. Okay, and then we will know the ratio of contribution in the energy densities. So we will know the ratio of contribution in intensities. Okay. Now let's start with this formula, the energy density due to electric field. So we can write this as U average is equals to half epsilon naught. Now instead of E naught square, we will put C times B naught whole square. Okay. Yes. Now this is giving us C square B naught square. C square B naught square. Now what can we write instead of C square? Instead of C square, we are going to write 1 upon mu naught times epsilon naught. And the other things are half epsilon naught, and we have B naught square. Now something will get cancelled out. E naught cancels out. Wow. And what are we left with? We are left with half B naught square divided by mu naught. Okay, this is exactly equal to the energy density due to magnetic field. Yes. So the contribution to the energy density is similar. So the contribution to the intensity will also be similar. So the ratio of contribution is nothing but 1:1. That's great. And now we can go and mark option D as the right answer for our question. Here is an awesome question on magnetic field, and the question is based on solenoid. So the question says that there is a long solenoid of 50 centimeter length having 100 turns. It carries a current of 2.5 ampere. The magnetic field at the center of the solenoid is. So we have a nice solenoid and we know the length of the solenoid, and we also know the number of turns in the solenoid. We know the length, we know the number of turns. That is, we know number of turns per unit length. We know the number of turns per unit length also. The number of turns was 100 for the length of 50 centimeter, that is half a meter. So we know number of turns per unit length, small n is equals to 200. Now we also have some information about the current. It is 2.5 ampere and we have to find the magnetic field B. What is this magnetic field? Now, let's try to recall the formula of magnetic field in a solenoid. What was the formula? The formula was B is equals to mu naught Ni. Yes, N is the number of turns per unit length. And we said this was 200. And the current was given to be 2.5 ampere. And what is mu naught? Mu naught is nothing but 4 pi into 10 raised to power minus 7. Yes. So this will give us B. Okay. Now let's quickly calculate it. We can see we are getting 2000 pi into 10 raised to power minus 7. And this means we are getting about 6.28 into 10 raised to power minus 4. Okay. So this is the magnetic field B. And let's quickly go and mark option C as the right answer for our question.